Hi, Matt. It's great to see you. Thanks for talking with me today.
Yeah, no problem. Glad to be here. Glad to be back. Can't wait to do the podcast today. It's always great sitting down and having a conversation with you.
Well, you always have good information for our industry. So, what I wanted to talk about today is in a recent edition of the journal, we published an article based on a white paper from AMCI on stepper versus servo. And I'd like to know what was the idea behind that and why would a manufacturer use one versus the other?
Sure. Part of it, it really was born out of the fact that, us as a supplier, stepper motion products in, the Rockwell automation space, uh, I was surprised at how many times I would have conversations with customers, new customers, people we were introducing AMCI products to that really didn't understand how steppers fit into the industrial automation space um, versus, say, using servos. Uh, Servos became the go-to motion product probably 25 years ago or so in automation. People kind of moved away from steppers because back then they were really kind of really dumb devices meant for simpler applications. And servos really took off as, the go-to motion choice. So they kind of fell off to the wayside where people didn't really pay attention to them as a technology. So when we were talking to people about our stuff, they were looking for maybe different alternatives to servos to save money, or they were doing some automation of a mechanical process and didn't have a big budget. Steppers always showed up on their radar as what to be using. So there was a lot of educating we had to do when we were talking to customers. So we really just said, you know what, the best thing to do would be, we had a tutorial on our website, and that tutorial really had a lot of traffic to it. What is a stepper versus a servo? So we decided, why don't we take that information that's on the website, refine it, and turn it into this white paper? And it was really a big hit. As you know from the published article, when we go to distributors and we hand it out, people today really aren't that excited about literature when you drop it off. But when we dropped off the white papers, people really gobbled them up. They'd say, "Hey, can you get me a couple more of those? I want to hand them off to our automation manager. I want to hand them off to our mechatronics person." So it was really, that is really what drove us to making the white paper, and it really showing off as being a big success. Um, as far as why one would use another, stepper versus servo, that's kind of what the white paper lays out, and it really kind of boils down to the application itself. Simpler applications, say like a point-to-point move, moving into a position, maybe some very simple speed control. Uh, Steppers are a great solution for that. When it comes to high speeds, dynamic motion, very fast reaction times to commands, um, coordinating axes, servos really are the great choice there. And then it kind of boils down to kind of refining the application. How fast am I going? What's my budget? How much coordination do I have to do with the application? Kind of helps push the customer in one direction versus the other. That's kind of what's laid out in the white paper.
Yeah, and I'll include a link to the white paper in the episode description for people to get. So why are manufacturers so interested in this topic when you say they're looking to save money? Are they looking for energy savings? Are they looking for more speed? What kind of things are they looking for?
Yeah, I think it's a really popular topic. One, because in our space, our audience, everyone's always learning and looking for new things, to do things differently, to do things better, to do things more efficiently. So that's why I think the white paper was such a great topic. And when it comes to choosing, as far as when I'm talking about, transitioning from one to the other, where one can provide more efficiency, say with the stepper versus servo, really boils down to the way the technologies function and they're designed. There's some inherent cost savings of a stepper versus servo. Steppers tend to have lower cabling costs because they don't have, in most cases, don't have encoder feedback in the traditional sense with like you had a motor and a drive. So you didn't have to run encoder cables back. Servos tend to have, just by the motor construction, also a little bit more expensive. So, someone could transition from a servo solution to a stepper solution as long as it met the needs of the application, and they could save somewhere in the neighborhood of 30% or more per axis. Now, when you take a machine that might have 20 or 30 axes on it, that's a huge savings. So that's where we're seeing a lot of that motion where we're transitioning from steppers to servos. It's a lot of it is a cost savings, a cost-driven solution.
Mhm. So, excuse me, what comprises a stepper motor system and what types of integrated steppers are there?
Sure. So in a classic sense, stepper solution isn't very different from a servo solution. You have a controller that's going to send commands over to a drive, and then that drive would be connected to a motor. In a stepper solution, the controller would simply be outputting step and direction signals. It would go to a drive. The drive would simply amplify those step and direction signals and convert them to a DC current, which would then move the motor. Most of our customers and most of our applications now, especially clean pieces of paper applications, everything's going to an integrated stepper. That is typically now going to be either a drive and motor in one package, or the control, the drive, and the motor all in one package, 3-in-1. So as you can see there, there's going to be a very big cost savings because I'm going to save things on wiring, the number of components. I can save in panel space. It really helps transition, what was a classic system that took up a lot of space in a panel, getting everything out of the panel and onto the machine, saves on wiring, makes connections a lot easier. And one of the things that we did with our integrated motors, which was new when we were doing it, was we added multi-turn absolute position feedback, which was something steppers didn't do prior to that, or most steppers didn't. So we took something that was a great feature, because now when it came to things like linear actuators or lead screw, ball screw type actuation, in the past, you'd often happen to have end limits, to make sure you don't crash in one end or the other. By having a multi-turn absolute encoder, we now were able to reduce the number of components, because now they could eliminate those end limits because they knew exactly where they were all the time. So it really not only changed what they did as far as the motor drive and control solution, it started to extend itself outside in the mechatronics world, where we could actually start helping them remove components that added cost and installation time.
So these developments you're describing, how have you seen the technology close the gap between the functionality of steppers and servos? What's been your experience?
So when people ask me about that, really what I tell them is the steppers now, especially now that we have integrated motors with encoders, whether it's an incremental or an absolute, pretty much we can do just about anything you can do with a servo except go fast. Steppers, because steppers, especially in a DC powered stepper, they're limited on speed. They kind of start to give up, torque at around 900 RPM, 1000 RPM, depending upon the motor speed. Excuse me, the motor size. That can vary a little bit from, size to size. But I usually tell people at 1000 RPM, you probably want to start looking at either an AC solution for a stepper or a servo solution, because the steppers do lose torque at those speeds. But things like high speed, high accuracy positioning. We even do now some integration with the Rockwell motion axis, so we can follow an axis and do camming functions with our motors. So there's a lot of stuff that the stepper can do that servos traditionally owned the space. We're looking at doing things like torque control with steppers now, which people just wouldn't have considered 5-10 years ago. So like I said, stepper is pretty much a servo. Servo just goes faster.
Now, I know AMCI has integrated products, and your AMCI is a Rockwell automation technology partner. So talk about what that means, being a partner, and how your integrated products fit into the Rockwell automation space.
Sure. So, being a technology partner has helped AMCI over the last 30 plus years. And it's not any different when it comes to our integrated motors. By being a technology partner, it allows us to offer customization tools that allow our motors to get into Studio 5000 in a much easier manner than, say, someone who's not a partner. things like custom EDS files. So when a customer is creating a program, the way that the data tags are displayed, or the information gets displayed that we're either sending to or receiving from the motor, all get displayed with nice name tags instead of just saying input word 0, output word 0, and then having to have a manual figure out, okay, what is this one doing now? Those data tags are all named. And then secondarily, we also have a nice configuration menu that you can't have unless you have one of these custom EDS files. So setting up the motor is a lot more simple. We just go to open our pull tab, add in our configuration data, and it's already there. When I plug in the motor, it automatically receives the data. I don't have to do any sort of coding for it. There's nothing I have to do offline, programming set up offline with the motor. They just plug it in and go. And so, we fit really well into that space. We actually just released about a month ago some new add-on instructions for our motion products. We had in the past, every one of our integrated motion products, whether it was a stepper or integrated servos, each product had its own unique set of add-on instructions, or AOIs. And what that meant was, if someone had an application where they had a NEMA 17 motor and a NEMA 23 motor, they had to have two sets of instructions to do the same thing. So your programming kind of looked a little bit kludgy, because you're going, wait, do I have the correct add-on instruction? Is the data type going to match correctly? Now with the AOIs we just created we call our just motion AOIs, those AOIs are non-specific to a product. So whether I'm using an AMCI integrated servo, an integrated stepper, or one of our Ethernet IP integrated stepper drives, it's all the same instruction set. So it makes programming a lot simpler. It makes integration easier. And when we recreated these AOIs, we actually kind of mirrored the language that Rockwell Automation uses. So when their customers open up that AOI set, it's very familiar to them. They don't really have to relearn or learn something new to do the programming. They just drag it in. They go, oh, I got to do a jog. They grab the MAJ, throw it over. I need to do a reset. They just drag over the AMCI MAM or reset, and it just makes things that much easier for our customer base, which is the Rockwell Automation customer.
Those are huge advantages.
Yes, they are.
I mean, you can't get any better than that. And it's my understanding that you might have some new products coming up. Can you tell us about those?
Sure. Yeah, we have to kind of carry on the line of the integrated motors. At Automation Fair this year, we're going to be showcasing our new AC-powered integrated servo. It's a small little 400-watt integrated servo. Fits great into the space. We got a lot of feedback from customers that were using our DC servos, especially multiple motors on a piece of equipment. DC servo does require quite a bit of current, so it required larger power supplies. By going AC, we now can pull power supplies out of the equation, have lower current, larger bus voltage going to the servo. We can go a little bit faster, squeeze a little bit more power out of them relative to current draw. And then we're going to be talking about our new, what we're calling our high performance integrated steppers. So it's basically what we already have in the NEMA 23, but a power pack, so to speak. So for the similar frame size and same motor length, we're getting about 40% more torque out of it. So we'll be talking about that, along with being a high performance motor. It's also going to be UL listed. So we're seeing and hearing from more and more customers, even though they're lower voltage devices, 24, 48 volts on the integrated steppers, people want a UL marking, especially going into different countries. We've talked to customers in Canada, for example, that wanted to use our integrated motors but couldn't because it didn't have the CUL or the UL mark. So this will allow us to expand our market into different areas. We're hearing pushback from people in the medical industry as well. So, having that UL is really going to be helpful to us and to our customers.
And listeners, if you are going to the Automation Fair event in Boston, it's the week of November 6th, and you can see AMCI's products in booth number 687.
Yes, and you'll be able to speak to me.
Yeah, which is always a good, interesting conversation. I can testify to that.
Well, thank you.
So I thank you for talking with me today, Matt. This is really interesting. It's always educational. I always learn something when I talk to you. Thank you so much.
No, thank you. Thank you for inviting me. And
So
I look forward to seeing you in Boston.
I do too. It's not that far away either.
No, it's not. We'll be here before I know it.
Yeah. So as always, to our listeners, thank you so much for listening. I'm Theresa Houck with the Journal Magazine, and we will chat again soon.